Okay, so at long last, we have reached our first triangle unit. We will be doing triangles for the next 4 months, basically, around all the holidays. We'll finish in about February. This is going to be just a basic intro. A lot of this you should already know. So in a triangle, we have interior angles and exterior angles. Just like you would think, the interior angles are going to be the angles inside of a triangle. There are always 3 angles inside of a triangle. Likewise, the angles that are outside are the exterior angles. If there's 3 that are inside, then there's 3 that are outside. Exterior angles form a linear pair with the inside. So if this is the inside angle, here's its exterior. Likewise at each of the other vertices. Okay, super important, must know, key information for months to come. If you don't know this, you are going to really struggle through these next couple of units. This is called the triangle sum theorem. All it says is that the angles in a triangle will always add up to 180. We just said there's always going to be 3 angles inside of the triangle. So essentially, we will always have a setup that goes part plus a third part, because again, it's a triangle, there are 3 parts, should always equal 180. So the way I usually look at it, if all I'm working with is angle measures, I go ahead and I write equals 180 inside the triangle, so I know that's what I'm trying to get to. In this case, I have a question mark. I'm just going to replace it by x. I don't really feel like putting a question mark in an equation. So I know I should have 3 parts adding to 180. Okay, well, one of my angles is 40. One angle is 90. And the other one is x. Now, a lot of you might have been able to kind of figure out you're just going to combine and subtract, but if you want an equation, here it is. So that's 130 plus x equals 180. Subtract, so x has to be 50 degrees. Likewise, on the next one, I know I should equal 180 because I'm adding angles. 20 plus 130 plus x should equal 180. Again, make sure you have 3 parts. So 150 plus x equals 180. Subtract, and x equals 30. Now, obviously, we're not usually going to be that straightforward. Sometimes we might have some expressions instead of just numbers. So in this case, I know I'm still working with angles. Okay, here's an angle, here's an angle. I have to mark them different because I don't know if they're equal. So in this case, my 3 parts are 90 degrees. Okay, well, that's the given angle here. X plus 37, that's 1 part, that's 1 angle, and x plus 67. Then take a minute, take your calculator, combine. When I add 90 plus 37 plus 67, I get 194, plus there's 2 x's equals 180. When I subtract, a lot of people think we have a problem because we get negative 14. However, since we're just solving for x, it's okay if it's negative. X ends up being negative 7. If that bothers you and you feel like that's not possible, just plug back in. If I plug negative 7 into this angle, that gives me a 30-degree angle. If I plug negative 7 in here, that gives me a 60-degree angle. Those are positive, so we're good to go. If the angles themselves are negative, we have a problem. On this next one, it asks me for the measure of angle A. So just like we did before, I'm going to make myself an answer line so I don't forget to actually answer the question at the end. I know these 3 angles are going to add to 180. So 5x plus 8x minus 2 plus 65 should equal 180. It doesn't matter what order you add them in, so I'm just going to add them in the random order I have up here. 5x, 8x minus 2, and 65. So that would give me 13x plus 63 equals 180. Subtract. calculator so I don't make a mistake. 180 minus 63 is 117. I divide by 13 and I get x equals 9. However, I'm not done. The question asked for me to solve for the measure of angle 9, remember? Sorry, measure of angle A, not angle 9. That's why it asked us for that angle. That's why we set it up at the beginning. Okay, well, when I look at angle A is this angle here. So I'm going to do 5 times 9, which is 45. So the measure of angle A is 45 degrees. And so that's important information number 1. Triangles add to 180. You need to know that these next couple months. We also have ways of classifying triangles and naming triangles. Classifying is very, very vague. It's not very specific to one particular triangle. We can classify triangles based on their sides and how they relate. When all 3 sides are congruent to each other, this is called equilateral. Okay. It's usually indicated by tick marks, so these 3 sides are congruent. I know they're marked that way. We're good to go. It could also be indicated by values, so maybe I say this is 10 and this is 10 and this is 10. That would also tell me they're all the same. If 2 of the sides are congruent to each other, then the triangle is isosceles. I think of it as having these 2 S's near each other, so that's why it's 2 sides that are congruent. Again, they could be marked by a tick mark. They could be having numbers with them. The 3rd side usually won't be marked, but it could be. It could have double tick marks, or maybe it's labeled with a different number. Either way, we know it's isosceles. It could be turned sideways as well. It does not have to be up and down. Finally, the only other way to name it by its sides is if none of the sides are congruent. That's what we call scalene. Kind of just a random triangle. So we have a single tick, double ticks, 3 ticks. Maybe we have 15 and 17 and 8. They're all random. So sides could be equilateral, isosceles, or scalene. None of them are the same, 2 of them are the same, or 3 of them are the same. For angles, we actually have 4 possibilities. If all of the angles are acute angles, and they're not the same, so 50, 60, 70, then we have an acute triangle. It's okay if 2 of them are the same. It's actually okay if 3 of them are the same. But if there are 3 that are the same, so all of the angles are congruent, then the best name for that is equiangular. The angles are equal. So while it's still acute, you should use the name equiangular. It's more specific. Not only are they all equal, if it's a triangle, they're all 60 degrees. Because again, we have 3 equal angles. 180 divided by 3 is 60 degrees. You could be told they're congruent by single arcs or by the 60-degree angles given here. Okay, so we have acute and equiangular, which is a specific type of acute. If one angle is a right angle, okay, all it takes is 1. It doesn't matter what the other ones are, this will be a right triangle. Now, as it ends up, if I take that 90 degree out, we only have 90 degrees left to spread between 2 angles. So the other 2 angles will end up being acute. So this angle is something acute, I don't know what, and this is something acute. I don't know what, because I don't know if they're equal or different or what. Okay, they're just acute, that's all I know. Just like one right angle makes it a right triangle, one obtuse angle makes it an obtuse triangle. So in this case, 120 is our obtuse angle. Same idea as before. If I remove that 120, okay, well, that gives me 60 degrees left to split between 2 angles. They have to be acute for the other 2. So one obtuse means the others are automatically acute. So again, to recap, acute, they're all acute, right? One's right, obtuse, one's obtuse. It is important to realize a triangle is going to be equiangular if and only if it's equilateral. Okay, notice that if and only if it is a biconditional. So if I know the angles are all equal, then I know these sides have to all be equal. Likewise, if I know the sides are equal, then I know the angles are equal. So that works both directions. Knowing all the angles or all the sides really helps us have a really easy problem to work with. Lastly, naming triangles is different from classifying. Classifying kind of just describes them, how are their legs related, how are their angles related. Naming is kind of like naming your pet. You're not going to just call your dog, dog. You're going to give them a name. Like my dog is Lucy. I'm not going to just call this triangle, triangle. This triangle in the picture, I could call triangle CAT. Okay, so CAT. Notice those letters, those are the corners of the triangle. It doesn't have to go CAT though. We could rearrange it. It could go ACT, TAC. It doesn't matter as long as you use those three letters. So if I wanted to practice this, first thing I want to do is name it. Remember, names are specific. So for a name, I'm going to go to these three letters. So I could name this triangle. So we do put the triangle so we know it's not a plane or something like that. I'm going to name it ABC. I like to go alphabetical, but you could call it BAC, CAB, it doesn't matter. For classification by sides, I'm going to look at these three numbers. I have a 50, a 29, and a 44. Those are all different, so I'm going to say it's scalene. If I wanted to, I could go back here and I could mark those different. Doesn't matter which one gets tied. For the angles, I have a 35-degree angle. Okay, well that's acute. I have an 85. That's acute, and I have a 60. That's acute. All three are acute, so this is an acute triangle. Make it a little bit more complicated here. The hard thing about this diagram is that it's two triangles stuck together, and it's actually two triangles making one big triangle. So I'm going to draw this so I have separate little triangles. So this one will be A, B, C. I know I have 55, 55. This triangle is going to be the one on the right, so B, C, D. All I know right now is I have a 25 degree. And then I'll use the picture given to do the big triangle ABD. Let's start in this small one, ABC. I know these two angles are congruent. They're both 55 degrees. I can find this third angle because I can subtract 180 minus 55 minus 55. And when I do that, I get 70. Based on that, I know triangle ABC is acute because all of those angles are acute. The sides are a little bit trickier. I'm actually going to use the angles to help me get the sides. Since these angles are both 55, you'll learn next class, that makes these two sides congruent. Those angles are congruent, so the sides that are across from are congruent. If I have two congruent sides, that means my triangle is isosceles. I know the third side's not congruent because 70 is a different value. Next, let's go to CBD. To do CBD, I do need a little bit more information. So going back to my big triangle, I found out that this angle here was 70 degrees. We just did that. So if that's 70, I can use linear pairs to figure out the angle next to it, right? Two angles that are next to each other make a linear pair. So if this angle is 70, then this one here has to be 110. Okay, well, if that's 110, I can find this angle because they should all add to 180. So I can do 180 minus 110 minus 25. When I do that, I get 45. So naming CBD, or classifying it, I should say, it has an obtuse angle, so it is obtuse. Because all of the angles are different, that means all of the sides will be different, so it is also scalene. Okay, lastly, we have this big, huge triangle here. I have the 70, I have this 110, I have this 45. I'm going to go ahead and scratch off some stuff that I don't need. So the only angles I care about for A, B, D are the ones at A, B, and D. So I care about 55. Angle B is this angle here. So I care about these together. And I care about 25. I don't care about 70 and 110. Those were for the smaller angles. Okay, so if I add 55 and 45, I get 100. So I have a 100-degree angle, a 55, and a 25. This has to be obtuse because there is an obtuse angle. Then 155 and 25 are all different, so this will end up being scalene. But if the picture's complicated, break it down. We do have some special parts we need to name in an isosceles triangle and in a right triangle. In an isosceles triangle, we have two legs. Okay, so two S's, two legs. The legs are what the congruent sides are. So in this case, this side and this side. Again, it could be tipped upwards, in which case these would be the legs. The other side that is not congruent with the first two is called the base. Notice I gave you a sideways triangle so that you didn't think the base had to be on the bottom. It doesn't. The base is the non-congruent side. The base angles are attached to the base. They are congruent because they are across from congruent sides. Remember, we said that works both ways. We'll talk about that next. The angle that's not congruent is called the vertex angle. We don't talk about that too much. For a right triangle, we also have two legs. The two legs in this case make this right angle. The third side is called the hypotenuse. Long word, long side, longest side. We will spend a whole unit just working with right triangles. Okay, so looking at triangle A, B, C here, I see a right angle. So based on angles, I know it's a right triangle. I could name it CAB. Oh, I need the triangle though, so let me squeeze that in there. Triangle CAB or BAC or BCA, it doesn't matter. Based on its sides, I know this is the longest. So if I have a 4, a 12, and something longer, then I know it has to be scalene. All the sides are different. The vertices would be the corners of my triangle. So A, B, and C, because vertices are points. The legs of my triangle are going to be sides. That makes a 90-degree angle. So in this case, segment BC and segment AC. Remember, don't write BC and AC because then you're talking about the 4 and the 12. You're not talking about parts of the triangle. Hypotenuse or base, this is a right triangle, so it is going to be a hypotenuse. Base is for isosceles. And in this picture, it's segment BA or AB, it doesn't matter. Finally, last but not least, is this random exterior angle sum theorem. The reason this works, let's call this angle here, this green one, angle 4. Okay, well, I know 3 and 4 should add to 180. Because they're a linear pair. I know that 4 and 1 and 2 should add to 180 because triangles add to 180. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 should also equal 180. Okay, well, if they both equal 180, then they have to equal each other by the transitive property. So measure of angle 3 plus measure of angle 4 equals measure of angle 1 plus measure of angle 2 plus measure of angle 4. Okay, well, they both have measure of angle 4, so when I subtract that out, I'm left with 1 and 2 add up to 3. That was a really long explanation for what I basically think of as the inside plus the inside equals the non-touching outside. Okay, by non-touching, I mean here's an inside, here's an inside. This outside, this exterior angle, is not touching either of these. So I just use inside plus inside equals outside. It's an easier way to think about it, but I want you to understand where it came from. So if I look at this, I see 2 inside angles and 1 out. So I go in plus in should equal out. So x plus 72 should equal 2x minus 11. Subtract x, so 72 equals x minus 11. Add 11, so 83 equals x. It does also ask me to find the measure of the exterior angle. Remember, that's the outside one, so that's this 2x minus 11. So I'll do 2 times 83 minus 11. Let me get my calculator. That'll be 155 degrees. I'm going to do a couple more just to make sure you're getting this idea. So again, I want to solve for x. There's 2 that are in and 1 that is out. So inside plus inside equals the outside. 110 plus x should equal 4x minus 7. Subtract x, so 110 should equal 3x minus 7. Keep writing in a minute. Add the 7, so 117 equals 3x. When you divide, you get x equals 39. And again, we want our exterior angle, so I'm going to do 4 times 39 minus 7, which is 149. So 149. Finally, this last one. Anytime I have an angle with a nice little swoopy arrow, it means I couldn't fit the label in the angle, but I'm talking about that top corner. So just like 4 in plus in should equal out. So 3x plus 7 plus 9x minus 5 should equal 158. 3x and 9x is 12x. 7 minus 5 is 2. So I have 12x equals 156. When I subtract the 2 over, let me do 156 divided by 12. X equals 13. And I'm 1 step away. Exterior angle. Actually, I'm not 1 step away. In this case, I already knew the exterior angle. It's 158 degrees. I'm done. That one was easy. So those are your Intro to Triangle basics. We'll do a little bit more on this stuff next class, and we'll do a review activity, but you do need to make sure you kind of understand these. Do the homework. I'm not posting the answers to the homework on Google Classroom. You'll be turning it in and graded for accuracy. So make sure you do attempt and make sure you go through these notes.